everyone, welcome to Ecoholics. In our previous video, we have discussed a numerical based on cost function. In this video, we'll be discussing another numerical based on cost function. So, we have this question. A biscuit producing company has the following variable cost function as total variable cost is given as 200Q minus 9Q square plus 0.25 Q cube. If the company's fixed costs are equal to 150 lakh, find out total cost function, marginal cost function, average variable cost function, and at what output level marginal cost will be minimum. So let's look at this example. So what we are given is now, next it is given that our total variable cost is, so our total variable cost is 200Q minus 9Q square plus 0.25 Q cube. So we have 200Q minus 9Q square plus 0.25 Q cube. So this is our total variable cost function. So this. Now what we are asked is, first we are asked, we need to find total cost function. So we already know that first we need to find what? We need to find our total cost function. So we know that total cost is equal to total fixed cost plus total variable cost. Now it is given that total fixed cost is 150 lakhs. So we are going to just substitute the value of total fixed cost, that is 150 lakhs plus total variable cost. So our total variable cost is this, that is 200Q minus 9Q square plus 0.25 Q cube. So this becomes our total cost function. So we have this as total cost function. We can just arrange this. What we get is total cost is equal to 0.25 Q cube minus 9Q square plus 200Q plus 150 lakhs. So this becomes our total cost function. This is our total cost function. Now coming on to second part of the question. Second is marginal cost function. So we have seen that our marginal cost is the addition that is made to the total cost by employing or by adding one extra unit of output. So we know that marginal cost is the addition that is made to the total cost by producing one extra unit of output. So marginal cost is given as this. Total cost of n unit minus total cost of n minus 1 unit. Or we can also write this as marginal cost is equal to derivative of total cost divided by this. So this is our marginal cost. So now we'll calculate marginal cost function. So second, marginal cost function. Now, marginal cost is equal to differentiation of total cost with respect to Q. Now, our total cost is given as, from our previous slide, what do we get as? Total cost is 0.25 Q cube minus 9Q square plus 200Q plus 150 lakhs. So, we'll write this over here. 0.25 Q cube minus 9Q square plus 200Q plus 150 lakhs. So this is our total cost function. Now we need to differentiate it with respect to Q, and this gives us marginal cost. So differentiating total cost with respect to Q, that is 0.25 Q cube minus 9Q square plus 200Q plus 150 lakhs. Now, this gives us, now in our previous videos on rules of differentiation, we have studied that when we have, so we have studied our addition rule of differentiation. Addition rule of differentiation says that when y is equal to u plus v, where u and v are differentiable functions of x, then we have dy by dx as du by dx plus dv by dx. So using addition rule of differentiation, what we get is, we have this. So here we have used addition rule of differentiation. Now we need to differentiate these terms. So what do we get is, our marginal cost is equal to differentiation of 0.25 Q cube. So this can be written as 0.25 differentiation of Q cube plus, this can be written as minus 9 differentiation of Q square plus, this can be written as 200 differentiation of Q plus, this will remain as it is, that is differentiation of 150 lakhs Now, we have 0.25 differentiation of q cube. Now, in this case, we are going to use a power function rule of differentiation. So, power function rule of differentiation states that power function rule of differentiation states when y is equal to x raised to n, our dy by dx is going to be equal to nx raised to n minus 1. So now in this case we have n as 3. So what do we get as marginal cost is equal to 0.25 into, in this case n is equal to 3. So we get 3q into 3 minus 1 is 2 plus minus 9 into differentiation of q square. In this case n is equal to 2. So we get this as 2q raised to 2 minus 1, that is 1, plus 200 into differentiation of q. In this case n is equal to 1. So we have 1 q raised to, now 1 minus 1 is 0. So this is 0 plus differentiation of 150 lakhs. Now we have already studied that differentiation or derivative of a constant term is always 0. So this term will be equal to 0. So now further simplifying this, what we get is marginal cost is equal to 0.25 into 3. This becomes equal to 0.75 q square plus, now minus 9 into 2 is minus 18. So we are going to write this as minus 18 q plus 200 into q raised to 0. Now we already know that q raised to 0 is always 1. So this will be just 200. This is our marginal cost function. Now this completes our second part, that is marginal cost is equal to 0.75 q square minus 18q plus 200. Next is find average variable cost function. So third part is average variable cost. Now our average variable cost is given by, so average variable cost is equal to total variable cost divided by Q, that is total output produced. Now it's given that our total variable cost is 200Q minus 9Q square plus 0.25 QQ. So our total variable cost is 200Q minus 9Q square plus 0.25 QQ. And now dividing this term by Q. So what we get is our average variable cost is equal to this 200Q divided by Q minus 9Q square divided by Q plus 0.25 Q cube by Q. 0.25 Q cube by Q. Now what do we get as our average variable cost will be equal to 200 minus, now 9q square upon q. This gives us 9q plus 0.25 q cube upon q. This gives us 0.25 q square, and this becomes our average variable cost function. So our average variable cost function is given as 200 minus 9q plus 0.25 q square. Now coming on to D part of the question. At what output level will the marginal cost be minimum? So D part states that at what output, what is going to be output, what is going to be the output at which our marginal cost will be minimum. So we need to find this. But before that, we have seen that our marginal cost function is equal to, so our marginal cost is equal to 0.75 q square minus 18q plus 200. So this was our marginal cost function. So our marginal cost function was this. Now we need to find the output level at which our marginal cost function will be minimum. So now we have two conditions now. When we have maxima, what are the two conditions? So we have first order and second order conditions over here. So for finding the maxima or the maximum value, we have two conditions. We have first order condition and we have second order condition. So first order condition states that our first derivative should be equal to 0, and our second order condition states that in case of maxima, our second derivative or second order derivative should be less than 0. So our first order condition is the necessary condition, whereas second order condition is a sufficient condition. Now similarly, we have two conditions for minima as well. So for minima, or for finding the minimum value, we have two conditions. First, we have first order conditions. And we have this is for minima. So for minima, we have first order condition and we have second order condition. So our first order condition is necessary condition and our second order condition is a sufficient condition. So first order condition states that our first order derivative, we equate it to 0, and our second order condition for minima states that our second order derivative should be greater than 0. So our second order condition varies for minima and maxima. So using this concept, we are going to find the output level at which our marginal cost function will be minimum. So we will first find this first order condition. So our first order condition in this case will be differentiating marginal cost with respect to Q, and we are going to equate it to 0. So our marginal cost was this. We need to differentiate this marginal cost function to get our first order condition. So now differentiation of 0.75 Q square minus of 18Q plus 200 is equal to 0. Now we know that we have already studied addition rule of differentiation, which states that so we have already studied addition rule of differentiation, which states that when y is equal to u plus v, then our dy by dx is equal to du by dx plus dv by dx. So using this addition rule of differentiation, we are going to differentiate our marginal cost function. So this becomes differentiation of minus 18Q plus differentiation of 200. Now this becomes equal to 0.75 differentiation of Q square plus this becomes minus 18 differentiation of Q plus this becomes differentiation of 200, and we need to equate this term to 0. So we need to equate this term, that is first order derivative of marginal cost, to 0. So now this differentiation of Q square, in this case we are going to use our power function rule. So power function rule of differentiation states that when y is equal to x raised to n dy by dx is equal to nx raised to n minus 1. So in this case our n is 2. So what do we get as 0.75 into, so 2 into q raised to 2 minus 1 is 1. So this gets, we get 2q plus minus 18 into differentiation of q raised to 1. In this case our n is equal to 1. So we have 1 into q raised to 1 minus 1 is 0. Plus differentiation of 200. We know that our derivative of a constant term is always 0. So this becomes equal to 0 and we are equating it to 0 now. So now we have 0.75 into 2q. This gives us 1.5q. Now minus 18 into q raised to 0. So q raised to 0 is always 1. So this gives us minus 18. and this is equal to 0. So what do we get is, we get this as 1.5Q is equal to 18, and therefore Q is equal to 18 divided by 1.5, or we can also write this as, so Q is equal to 18 by 15 into 10. So what we get is 5 2s are 10, 5 3s are 15, 3 1s are 3, 6s are 18. So 6 into 2 we get 12. So what we get is, from our first using our first order condition, what we get is, we get Q is equal to 12. So we get the value of output as 12. But now we need to see if this is the output at which our marginal cost function is minimum. So for that, we are going to use our second order condition, which states that our second order derivative should be greater than 0. So let's look at this. We have our marginal cost function as 0.75 Q square minus 18Q plus 200. So this was our marginal cost function, that is 0.75 Q square minus 18Q plus 200. And we had our first order derivative as 1.5Q minus 18. 1.5Q minus 18 was our first order derivative, and we got Q as 12. We need to see whether at this output level our marginal cost is minimum or not. For that, we need to find a second order derivative. So our second order derivative will be so this is the condition for finding the minimum value. Now we are going to find second order derivative of marginal cost. So differentiating this term, that is differentiation of 1.5Q minus 18. This can be again written as now differentiation of 1.5Q. This is equal to 1.5 into differentiation of Q term. Now power function rule again. So using the power function rule, we get differentiation of Q as 1 minus differentiation of 18. Derivative of a constant term is always 0. So we get this as 0. So our second order derivative in this case is 1.5, and this 1.5 is greater than 0, and this was the condition for minima. So we can say that so what we have found is, first we had this condition, output of, that is at output level 12, our marginal cost function is minimum. So both our conditions are satisfied. This completes our answer. So we have seen how we can use concepts of cost function and solve such questions. That's it for this video. In our next videos, we'll be discussing other numericals as well. So do like and subscribe our channel. Thank you.